All right, we are going to begin Chapter 7 by doing a little review of actually some topics that we should be familiar with, systems of equations. So, Chapter 7 is titled Linear Systems and Matrices, and as the chapter goes on, we're going to start to introduce matrices, but right now, we're going to go back and I hope you're a little bit familiar. There's three ways to solve systems: substitution, combinations, and graphing. So being familiar with those terms is going to help you in this section. And the key here is I know you could do this one relatively easy by using combinations if you remember that method, but I do want to go back and say, all right, let's actually work on the substitution method, because that's what we're going to focus on today. And substitution is actually replacement. And the way I look at replacement, if I take this second equation and I solve for a variable, I just happened to solve for this x. I could have picked any variable in the whole problem to solve for, but I solved for that x. I now have this new statement, x is equal to 2 plus y. That means I could trade an x for a 2 plus y. They are exactly equal. And that's what I want to do in this top equation that I have yet to touch. I've got an x here that I'm going to take out of the problem. And I'm going to replace it with the 2 plus y that is of equal value. So this x is gone. In its place is 2 plus y. Then I copy over the rest of the statement, which is plus y equals 4, and I have a statement with one variable that I could solve. I could combine like terms. 2 plus 2y equals 4. From here, it's simple algebra. 2y equals 2. Divide by 2, divide by 2. I now know y is guaranteed to equal 1. And because now I know that y is a guaranteed value of 1, well, if I know that this value right here is a 1, then I better be able to figure out what x is. And the only possible value for x is 3, because x plus 1 equals 4. Well, subtract 1 if you really need to do that. And now you have your answer to this, 3 comma 1. And you could always worthwhile checking it here. 3 minus 1 is 2, so you do know you have the correct answer. It is the only correct answer. We are going to be building on this substitution as the lesson goes on with a few word problems. Here, a total of $12,000 is invested in two funds, one paying 9%, one paying 11%. We're going to call those both simple interest. The yearly interest is $1,180. How much is invested in each? Okay, so what's important to state here is the variables. There is money in the 9% fund, and we do not know how much money is in the 11% fund. What we do know is the total amount of money, which is one equation that we could create. We could create x plus y is equal to $12,000. What this statement is really saying, we have a total of $12,000 invested in two funds. X is the amount of money in one fund, y is the amount of money in the second fund, and total there is a $12,000 invested in both of them. That's what that statement is saying. The second one is the yearly total interest is $1,180. That interest is obtained by getting 9% and 11% simple interest out of those two funds. So if I know my fund is earning 9% of however much money I have invested, well, 9% of x would be 0.09x. And I also know that I'm getting 11% of whatever is in y, and when I total those percentages together, it adds up to 1,180. I now have a system of equations. Again, a system is just a fancy word for two equations with two variables, and I am going to use substitution to solve here. So in the last problem, I solved for x. Why don't I solve for y this time, just for a little bit of difference? Y is equal to 12,000 minus x. And here's where a substitution can happen. I'm going to take that y out of the problem. 0.09x plus 0.11 parentheses 12,000 minus x equals 1,180. Now this one's a little more complicated because there's some distributive property that I would need to do. It helps if you have a calculator. So I'm going to have 0.09x plus 0.11 times 12,000, 1,320 minus 0.11x equals 1180. So at this point, we got some like terms we can combine. Negative 0.02x plus 1320 equals 1180. So we will subtract the 1320 to both sides. Negative 0.02x equals, that's negative $140 divided by negative 0.02. So now I'm just solving for x. And if I have negative 140 divided by negative 0.02, I'm going to get, that should be, oh, I forgot a negative sign, so that should be positive. Oh, I have a point, that's why the whole thing's messed up. Let me do that one more time. Negative 140 divided by negative 0.02. This will be a better answer. 7,000 sounds way better. Don't think we had $7 invested. So that would mean there were $7,000 in the first fund. That first fund earned 9%. So that would put $7,000 here. And, well, I know I had a total of $12,000 invested. If you want to go back and you can deduce that information, if you know that this x is 7,000, well, then the y has to be 5,000. All right, and if you need the algebra to do that, fine. If you want to subtract 7,000 to both sides, 12,000 minus 7,000 is 5,000. So here are your two answers. If you want to write it as a coordinate, 7,000 comma 5,000 is perfectly fine. So I want to show you, so here we're going to do this problem actually two ways. We're going to solve it once by using substitution, another time by doing it on a graphing calculator. So first off, substitution. Pick any value, any variable, and substitute it. And solve for it. So I will solve for this y by adding x to both sides, and I have this statement: y is equal to 4 plus x. So here's where the substitution is happening. That x is coming out. That y is coming out. It is getting this y right here. That's what's getting taken out. It is getting replaced with 4 plus x, and it's equal to 3. Now, I know I say usually put parentheses here, but there's no distributive property necessary, so you don't really need those parentheses. What I do see, I see that this left-hand side, if I rewrite it, is really a trinomial. The problem is this trinomial is not set equal to 0. So I'm going to want to solve this by subtracting 3 to both sides. X squared plus x plus 1 equals 0. So I could try to factor this to solve it, but it's not going to be factorable. My only option would be a quadratic formula, and I could try quadratic formula. If I say opposite b, that's going to be negative 1 plus or minus b squared, so that's 1. Opposite b plus or minus square root b squared minus 4 times a times c all over 2 times a. The problem that happens here is I have negative 1 plus or minus the square root of negative 3. I would hope you're recognizing I can't take the square root of a negative number. So to this answer, I am getting no real solutions. No solutions. And that's the answer to this problem. What I do want to do is just look at this graphically in a second method, because it is going to help us. On a graphing calculator, I could do this problem. But the problem is a graphing calculator only works if you can enter in y equals. So I already knew that y is equal to 4 plus x. I also know here, if I subtract x squared, that y is equal to 3 minus x squared. I could have gotten this answer by looking on a graphing calculator, typing into my my y values, or my y equals key, 4 plus x over, 4 plus x is our first equation, 3 minus x squared is our second equation. I will look at a standard window to start, and I will be looking for where these intersect. And just on first look, I know the first equation is a line, I know the second equation is a parabola, and it looks pretty clear to me that they are not intersecting. Because they're not intersecting is the reason I'm getting no solution. So that's a way to verify on a graphing calculator. We'll look into that a little bit more in this problem as well. All right, so sticking with our theme of using substitution today, I'm going to solve for a variable. If I want to solve for, let's say I solved for this y, I could say y is equal to 2x plus 1 if I add the y and add the 1. So I have solved for y. That is getting substituted in for that y. So for that top equation would read x squared plus 4x minus parentheses 2x plus 1 equals 7. So we would need to do a little bit of the distribute that negative sign. That's first. And combine some like terms. I have x squared plus 2x minus 1 equals 7. And again, I see a trinomial. The problem is that trinomial is not set equal to 0. So let's set it equal to 0. X squared plus 2x minus 8 equals 0. This one is factorable. It looks like we have x plus 4 and x minus 2, which means I'm actually going to get two possible x values here. In the last one, I didn't get any. Here, I'm getting two solutions. Those two solutions for x would be negative 4 and positive 2. Now, I've gotten those both from the zero product property. And now I have to get my y values. All right, so what I really have here is two separate problems now. I got to solve when x is equal to negative 4. When x is equal to negative 4, let's look at this second equation because I think it's a little easier. If x is negative 4, it's 2 times negative 4 minus some value. It's got to equal negative 1. Well, that's negative 8 minus what equals negative 1. So if you add 8 to both sides, you're going to get negative y equals 7. So here, y would have to equal negative 7. One answer, negative 4, negative 7. That's one of our answers. The other answer, found the same way, 2 times 2 minus y equals negative 1. So I'm going to subtract 4, negative y equals negative 5. So you could say y has to equal 5. 2 comma 5 is my other answer. Now, what I do want to look at is, I know this equation. This equation is solved for y. I want to look in the graphing calculator, and I want to solve this top equation for y. Y equals, let's say, x squared plus 4x minus 7. If you add the y and subtract the 7, do pretty. So these two equations I want to put in a graphing calculator just to show you this method of graphing one more time. We are going 2x plus 1, 2x plus 1. First equation. Second equation, x squared plus 4x minus 7. I'm going to graph those on the same standard window. There's my first one. That was a line. There are two solutions, and the calculator can actually calculate those two solutions. If you type in second trace, that's the calculate function. If you ask the calculator for the intersection of two lines, what the calculator asks is, what's your first curve? If you notice, if I hit the up and down arrows, it's jumping from the two curves. I select the first curve I want to intersect. Now I select, I'm on the second curve, and it's going to ask me for, I hit enter on the second curve. Oops, what's going on there? Enter on the second curve, and it asks me for a guess, something close to my intersection. 2, 5 is where those two graphs intersect. So I would need to do that process one more time to get my other answer. It's first curve. I'm just going to move the cursor a little closer to the answer I want. So there's my first curve. Then I move the cursor so that it's on my second curve. You can see it on my other curve. And then I got to get close to where they intersect, and I hit enter a third time. And negative 4, negative 7 is my other answer. All right, so the key to these slides has been using substitution to solve systems. We will look at it. In fact, actually, why don't you copy? We will look at this word problem in class together to see how we can continue to use systems to solve this equation based upon businesses. Copy it into your notes. Be ready to go at the beginning of class tomorrow. Bring your questions to class. I will see you then.